All right. Hello, hello. How's everyone doing? I know it's a very short lunch break. For some reason in my head, I thought we had 20 minutes, but it was actually 10. I hope everyone's been enjoying the Chicago Roboto so far. I've been really enjoying all the talks I've been seeing. And we actually, to finish out our Compose hour, we have Ben, who will be talking about prototyping with Jetpack Compose. Welcome, Ben. It's really great to have you.
Thank you.
All right. We're just going to send it off. Really looking forward to that talk.
Awesome.
Thank you.
So if you caught the tail end of Vishnu's talk, he mentioned, getting in there and really just playing with Compose. And what we'll be talking about here is how I had fun doing just that. So let's kick it off. A little bit about myself. I'm an Android engineer at the New York Times. Been there for 3.5, almost 4 years. I'm having fun on the games team. So we started out doing the crossword puzzle, and we have now we've got other mobile games like Spelling Bee that we just released. Really fun. Check it out. And I'm on Twitter. My handle there is Ben Likes to Code. So this is my journey into Compose. One of the things we have at the Times every summer is called Maker Week. And it's a week where we can just clear calendars, decline meetings, and really dig into something new that you want to learn. And a lot of people use this as an opportunity to maybe learn a new language or prototype an internal tool or, just kind of scratch some itch they have. And last summer when we had Maker Week, Google I/O had just happened. And we had an opportunity to kind of poke around at Jetpack Compose. So what I set out to do was to re-implement a prototype of the mini crossword in Compose. And kind of the rationale for doing this is that it's a cut down version of the real puzzle. So unlike the main daily puzzle we have, it's a 5x5 grid. You get into Sundays, it's much bigger. It's a real easy solve. People do it in under a minute oftentimes. My personal record is 7 seconds. It's free to play. And moreover, we have fewer of the weird sort of special puzzles that get tricksy. So you get into the daily puzzle, especially on Thursdays where we have Tricky Thursdays. Sometimes you find puzzles that have more than one letter in a square, or we have sometimes we have, fancy graphics that come up when you solve, and the mini doesn't really have that. So it's a nice, easy problem surface to attack, to try and play the crossword, but also not have a lot of the corner cases that might make it complicated. So let's get down to brass tacks here. When you think of a view in Compose, you're really looking at a tree. You've got, the trunk of the tree and the tree itself kind of represent the whole of things. But then you get out to the leaves, and these are sort of the atomic pieces of your UI. So what are the leaves in a Compose view or really a crossword in general? What's like the most bare minimum part of a crossword we can kind of decompose into? We got black and white squares. So you look at the puzzle, we have black squares that are dead. We have white squares that you can put a letter into. So how would we implement this in Compose? To get a square, you need it's kind of like that old Foo Fighters album from the mid-90s. You need a color and a shape. So we'll create a box. We'll give it a background color that's passed in from this function. And the modifier is a way to pass in layout configuration. So we'll also wrap this color background in some easy convenience method for white squares and black squares. And we'll also pass in a modifier in there to make it fill the size of its parents. So these are going to be a black square and a white square that kind of expand to fill the entire available space that they're given. So what does that do for us? Let's go over to the preview in the Android Studio view. So this is a thing you could actually just paste right into Studio. So we're going to go ahead and take a white square, and we're going to pass it a modifier itself right here to say preferred size, which is the size on either dimension, height and width. So we're saying we want a white square that's 100 dips high and 100 dips wide. And we're going to put these, the same for a black square, we're going to put these in a column. And so when our preview shows, we get these things stacked top to bottom, a white square and a black square in a column. Really easy. And there's our basic building block of a square. So we're done, right? Well, not exactly. So let's look back at the puzzle. We don't actually have just white squares and black squares. We've got white squares and black squares and yellow squares and blue squares. What do these mean semantically, and how do we model this in our Compose UI? So your yellow square is where your cursor is. It's where it's the box you're actively going to type into. You have the blue, which is the clue you're actively solving. So in this case, I'm solving Nevada neighbor, and I've misspelled Utah. And then you have the white squares, which are the squares that you either have already filled in or that you haven't gotten to yet. So how can we model this? So let's just create a data model here. We'll create an enum here for selection mode that kind of maps no selection, having your cursor, and then also the active clue, a cell in the active clue. And then we can create another enum with the background corresponding to these different states. So we'll create an enum with the cursor color, the active clue color that map back to this view here. So now we can pass in, what we want to be able to do is pass in a selection mode to that white square. So we can say it's a white square, but here's how we got it selected. And then we'll create a helpful mapper that translates a selection mode to one of these cell background colors. And finally, now we can use that same colored square background that we had been wrapping, but now this time we're going to pass in that appropriate color. So now let's go back to our preview. And here we can say, here's white squares for the active clue, the cursor, and no selection. And here is the corresponding views. So looks great so far. Now we want to do what's important next is these squares have letters inside them. It's not a very fun crossword if you don't have anything in the boxes. So we're going to add another parameter to our white square for text. And this is going to be nullable because you may not have typed something in that square yet. So now we're going to change up our layout here inside this white square. So before we had just wrapped the background. Now we're going to put that inside of a stack. And so a stack is a Compose layout where you can position them with gravity. You can position a view within a gravity setting inside that layout. And we'll demonstrate this as we go. And then as you add things to the stack, you're creating layers. So the first thing that goes in is at the bottom layer. Anything you define after that is put on top, and so forth and so on. So the first thing we're to define here in this stack is a background for the square. So we're going to drop in that color background with the right selection mode. And we're going to tell that background we want to fill the maximum size of our white square. And we also want to use gravity. We want to drop that right in the center. And that's kind of, we'll see some other examples of gravity here and how we can use this. But what we want is for this to land up right in the center of the view and fill it. So next, we're going to take our stack and add a text view. So since our text is possibly nullable, we don't want to do this until we actually have a value. And so we'll go ahead and put that user answer that the users typed in. And we're also going to put a text view similarly with gravity and center. And when we do that, we look at our preview and we can create, I'm going to make a big square and a small square sized. And we've got that text in the center. But my designer comes to me and he says, "Hey, Ben, it's great you have this in the center, but it doesn't really scale with the size of the box. I really want it to be 60% of the height of the box I want to be the letter. And so that way you have big box, small box, the letter looks nice no matter what you do. So how do we do this with Compose? It'd be really cool if we had an easy way to measure that box and know the height and the width, and then use map to decide what our text size should be. How can we pull that off? What's really cool is it's actually really easy with Compose. So we're going to wrap our stack now in this block here with constraints. And when you do this, you end up with the ability to query the constraints that make up your sort of the view you're drawing within. So here we're able to, now that we call with constraints, we get for free this max width property that we can use. So we want our max width to be 60% or 0.6. Now, what is this with density ambient going on though? So we heard a little bit about ambience in the last talk, but there are also some ambience you get for things like device density and context that we can use to do, in this case, we're going to do some dips to pixels to SP map. So we're going to get our maximum width and we're going to convert that to pixels. And then we're going to get 60% of that. And then we're going to convert that to SPs for text size. And this is like a crazy easy way to manipulate these density dependent values from how it used to be in the old world of Android views. If you've ever looked at trying to convert pixels to dips and back, it's a lot of boilerplate that people end up creating a helper method for somewhere in their project. And you don't need to worry about that here. It's all right here with this density ambient does it for free. So we're going to do a text size that's going to be in SPs. And now we can define a style that we're going to apply to that text that specifies that size that we've derived. And so now we go back to our preview and we are growing our text size to fit the box. Really cool, really easy. And again, like you look on Stack Overflow and how to calculate dips from pixels and back and forth is, a perennial question on here. And the density ambient does all the heavy work for you. So you'll never have to go back here and look again how to do it and map out device density to pixels to dips. So another thing we have in the puzzle is a cell number. So, a crossword clue is often defined as, 2 across or 4 down, what have you. So we need to have a little cell number up in the top left corner. So how do we pull this off? So first, let's add another parameter to our white square for the cell number. And again, this is also going to be nullable because not every cell has a number. We're going to calculate ourselves another text size here. So this time I want it to be 15% of the size of the square's height or width. And then I'm going to go to the stack and we're going to create a text field for a cell number or text view for the cell number if we have one. We're going to use that number size. And now here's another use of that gravity. So this time we want it to be aligned to top start. So this would also, I actually don't know how they solve crosswords in right to left languages if the clue number is at the top right. But if they did, this would get you that, because Android's start and end is going to account for right to left, left to right switches, locales. So, but we're going to say top start. And so on our lovely left to right locale emulator I'm running, it's going to put the clue number at the very top left. So now we look at our preview, we drop in a cell number, looks great, and it's nicely proportioned and hanging out up there in the corner. Now, one thing I did not account for here when we talk about the cell view is how do you handle if you have to put more than one letter in a square. And I actually haven't figured out yet a good way of doing measurement for the text field so that something similar to like an auto-sizing text view in the Android view world. So I'm all ears if any of you know a good way to do that. So let's go back to our example here. And again, here's me. I misspelled Utah, and I went and checked my work, and it's put a nice strikeout through that one square. So we want to implement checking our work. So how do we do this in Compose? It's real easy. So we're going to create another composable here called a strikeout view. And we're going to calculate the width of that slash that we're going to draw. So again, our density ambient comes into play. Here we're going to convert 5 dips to pixels so that we're going to have our drawing needs to be defined in pixels. Next, we're going to go to the, we're going to use a canvas. We want that canvas to fill the friendly confines of the view we're going to draw in. And then we're going to use the canvas to draw a line. We want a red line. We're going to use an offset that's going to start in the top right corner and another end offset that's going to be the bottom left corner. And we're going to give it that 5 dips in pixels form. So now in our stack, real easy, we can add a strikeout parameter in the composable going in. And then we'd say, if we have a strikeout, then do it. And this will draw that strikeout right across the square. And since it's the last thing we define in the stack, it paints over everything else in the square. So drawing is a really cool and easy thing you can do with Compose. It was surprising to me how simple that was. So we've created some simple composables for showing how to take essentially parts of the board, parts of the squares. But let's kind of adapt this to a data model. So let's build out a enum here for square type that's going to define, let us classify a square as to whether it's a dead square that's black or if it's a square you can put a letter in. So then we're going to build a square model that kind of embodies a lot of these things that we've put into that square composable. So we have the square type, we have the actual answer that square should have. We've got a cell number if that square has one. The answer the user has typed in if they have one. Whether we've asked to check if that square is correct or not, and I'll show you how that works later on. And then we have the selection mode is, whether a cursor or is on that square or not. So we've put all these things in a square model. And then for the purposes of creating a data source in the test app, I've got some friendly convenience constructors here that let us say something like this. So we can create a letter square now and pass in a square for which the answer is A. So now we have a model-driven square. Instead of just the white square, we have one that's 4 letters that accepts one of these square models. Similarly, we want to build a data model for our puzzle. So we'll have a class here called board, which represents the game board. We want to know it's a 5x5 grid, so we're going to say the count on the edges is 5, and then we're going to have a list of squares. So in a 5x5 board, we'll have 25 squares. You can kind of see here we'll have the top row. So our top row has a black square and then 4 letter squares. So now that we have a board with a list of squares, we can go ahead and render that board. So let's walk through each step of this. So we're going to take our squares, and then we're going to use Kotlin's chunked collection method to give us groups of squares. So we want to get basically 5 groups of 5 for a 5x5 puzzle. So board's edge count is going to be 5 here. So this is going to give us chunks of 5. And since it's 25 elements in the square, it's in the board, it's a square. This is going to give us 5 rows. So now we can iterate over those rows and define a row layout in Compose. And then we can iterate over each of those 5 rows of squares and key off of that type of square that we put in there. So if it's a letter square, we're going to pass in the letter. And if it's a black square, we're just going to do a black background. And so this is where we're going to use that model imbued letter square. So we do this and we get a board with no grid lines. So how do we do that? Well, one thing I had done before with Compose back last summer before redoing it after the alpha builds came out was I used a layout that they had in Compose called a table layout. And the table allowed you to do define grid lines as something you kind of get for free. And the table layout did not get a lot of love as the Compose API iterated, and they removed it. So I wound up implementing something with some clever uses of row and column and drawing. So I'm going to, in the interest of brevity, I'm going to spare us that here, but it is in the example project. So I encourage you to, if you're interested, check out the example project on GitHub. I'm going to put the link for that in Slack, and the URL for it is also at the end of this presentation for you. So a crossword also has clues. So how do we want to model our clues? So a clue is a collection of a few things here. It's the direction that clue spans in. So every clue is either an across or down clue. There are cells that make up that clue. So these are the cells that you have to fill in to solve that clue. And then there is the text that embodies that clue. So we'll define a data model for all of our clues that includes the cell indexes for the squares that map to those clues. And we'll add that to our board. Finally, we're going to make a board, a view model that embodies the board. So I've kind of elided some of the guts of it, but the sort of interface that this board exposes is one for keying in a letter. So as you use the keyboard to type a letter, we need to be able to fill it in. And then we need to be able to react to when you select a square and update the state to show which squares are selected. Finally, we want to make the game board actually interactive. So we want you to be able to click on a square and have it react. So how do we do this? Well, we're going to pass in a onClick method into the game board. You're going to define this lambda that takes a square and does something when you click a square. Now, since we're also going to pass that onClick down into the letter square so that the letter square knows what to do when you click, so that event can bubble back up. So now we get to the letter square, and that's another parameter. And now we get down to this level, and our box that makes up the letter square, we're going to add a modifier called clickable. And when this will cause it to call that click method when you click on the box. And what's cool is that when you add clickable, it even adds a material ink ripple right onto the view, and you get that for free. So now let's go into our main activity where we're actually using all these things. So we're going to react to our view model's state of the board, and we're going to drop in our game board with its squares. And then we're also going to pass in the method here. This is the onClick method that we're going to use. So our view model has a select square method. So we're going to call that select square on the view model whenever someone selects a square on the game board. We're also going to add a view that shows the selected clue. And this clue bar, I don't have it shown, but it's just a blue box with a text to you. We'll see how this looks in a minute. But what ends up happening is that when you click on a thing in the game board, it's going to propagate that state back up to the view model. The view model will have its select square invoked. It will update the state, which will then be pushed back to the game board in the clue bar. So let's take a look here on the video. We got our clue bar at the bottom. We got the game board. Now I can click around. We get that cool material ink blot for free from asking for it to be clickable, and you can navigate the board. So that's pretty cool, but we can't type anything in. So how do we do that? And to do that, I thought, let's try something creative that you couldn't do before with some of the earlier versions of Jetpack Compose that I had played with. But since then, they've added the ability to add old school Android views into a Jetpack Compose hierarchy. So how do we do that? I thought what would be cool to do is add a old style keyboard view into our hierarchy, so you can go and type like that. Now I know this has been deprecated in the latest platform, but for the keyboard view, that is. But for sake of demonstration, it seemed like a cool thing to do. So in order to instantiate an old school Android view, you need a context. Luckily, there is another ambient that's there to help us for that. So we can get the current context via an ambient. So now we're going to instantiate a keyboard view just like we always would. And the keyboard view takes an XML resource that defines what keys that are beyond there. So since we don't put in numbers or special characters in a crossword, I've defined a simply alpha keyboard that we pass in. Finally, you get a Android view composable that you use to wrap that keyboard into the and adapt it into the Compose world. So here we're able to add a listener to that keyboard view so that it will do something when you click one of the keys. So I've added an on-key clicked method into a parameter into the this composable going in. So we'll make use of that when you tap a key on the keyboard view. So we'll just go ahead and convert that key code to a character string and pass that back up the chain. So now we can go back to our board, and we can add that custom keyboard. And here we're going to call when there's a new key entered, we're just going to pass that right up to the view model. And again, the view model will do its thing, update the state. The board subscribes to these changes, and so these all propagate back down. So these events, in the Compose way of thinking, events bubble up and data flows downward, and so that's what we have going on here. So it's not the prettiest keyboard, but let's take a look at the video. Now I can start selecting some squares, and I'm going to start typing into the puzzle. And here we go, we're solving the mini. And again, as we type into the board, this is an old Android view that's going up and posting these changes to the view model by way of the event bubbling up the chain. And then we're letting the board react. So the final feature we're going to add is checking our work. So we had we built that strikeout before in our letter square. So let's make use of that. And we also remember that we added a checked Boolean onto the square itself to indicate whether we've asked that square to check its work or not. So here we're going to say if in our stack for the letter square, we're going to say if we've got an answer in that square, then if that square is checked and if it's wrong, we're going to drop that strikeout into our view. And so that'll be the last thing in the stack, and it will draw a big angry red line over the wrong answer. So again, our checkboard, we're going to add this method onto our view model. And so this is just going to add that checked property, make it true on each of the squares. And so this is also going to update that list of squares so it shows as a change to emit in when the state changes. And then finally, we're going to add a button at the bottom of our column here that will trigger checking our work. So when you click it, you're going to call that checkboard method on the view model, which is going to set checked on each of the squares. And we'll add a test view explaining what this button does. So now we can look at the puzzle again. We've got a kind of ugly check your work button at the bottom. It is not pretty, but this is a prototype. That's the name of the game, is make it work. So now we look at the video. I'm going to check my work. It's going to show me the wrong answers. And then I can go in here and change them to the right ones, check my work, and then watch as the red slashes all disappear. So we did it. What did we do? So we built a Jetpack Compose UI around a data model that's pretty similar to what we use in the shipping crossword app. So it's something that's kind of an easy idea for us to think about when we're prototyping, and then also maybe an easy lift from a prototype to maybe someday we want to actually use it. So we also, we decomposed the UI into its most basic components and then rebuilt it from those leaves of the tree back inward. And hopefully we had some fun doing it. I really had a lot of fun watching the puzzle come together from little bits and bobs into a puzzle. And it was even more fun to watch this stuff later on as the tools got better, to see it right there in the Android Studio preview UI, that I didn't even need to run a device until I wanted to add interactivity to it. So some parting gifts for you all. This is a link to my GitHub repo with the example project and also PDF and Keynote versions of these slides. So you can see the entire playable version of the puzzle and check it out yourself and see what I've done here. And especially if you're interested in how I got around the question of adding borders to the squares in the puzzle. And then also the full implementation of the view model is in there if you want to see how that logic plays out. So again, here's the URL for that, and I'm going to paste that into the Slack when we're through. So yeah, thank you very much. And PS, we're always hiring, so look us up and tell them you came from Chicago Roboto, because we definitely want them to know, the recruiting folks at the Times know that conferences are where people are coming and hearing about us from. So with that, yeah, let's open for questions.
Yeah. All right. Thank you so much for the presentation. This was a really great presentation. We already have a couple questions
Cool.
your way. So first one, they want to know if they can get a link. But yeah, I know you just mentioned, you said that you're going to paste it in.
Yep.
Okay. First question. Can I make Compose View as a custom view to make UI and communicate via state or view models?
You can do both. So there's some of the new, the latest stuff in the Compose SDK has some view model plumbing. So you can actually hang off of a live data or use more Compose first state in a view model as well. Or you can use state within your Compose views. But what's really cool is there's a way to observe off of live data right there in a view model. So if you have, if you need compatibility between a view model that's providing, data to an old world view and also a new one, you can handle both sides of it.
All right, and sorry about that. What you just heard was the Chicago Brown line. Kind of cut me off in the middle of the sentence. Okay, next question. How hard do you think it would be to generalize this to the full crossword version?
So one thing that I'm really interested in playing with after, later on is the Compose SDK added a easy zoomable, I don't know what you want to call it, but a means of making views zoomable. And this would be really handy in some of the bigger puzzles like the Sundays. Like we added a pinch to zoom and pan in these puzzles because, they're...
Oh, that's okay.
Yeah, okay, there we go, sorry.
Sometimes it's Chicago, sometimes it's friends. Yeah. It may be like that.
Okay. So yeah, where was I? So one thing I'm really interested in looking into is the pinch to zoom that we can do with Compose, and see if it's any easier than our means of doing it before with Android views. And then the other question is, I mentioned auto-sizing text views for the ability to put more than one letter in a square. And so that's something I want to look into as well. But I think the bones of it are there. And it was really surprising how well it came together. And, what I'm really excited for the simplicity that this imparts and really getting the view closer to the data. I think it's the kind of thing that probably would bring a lot fewer sort of interaction plumbing going on.
All right. Thank you, Ben. Let's see. I think I still see some people typing in the chat. We're just going to give it another minute or two for any additional last minute questions.
Sure.
Folks, for Ben, who's still online for everyone. And of course, if you have questions after the fact, you're still welcome to use the channel too. Yeah. Oh, okay. We do have another. Okay, so not sure if you talked about this already, but did you end up experimenting with animating the keyboard in and out while using Compose?
I did not. In this example, we just plop the keyboard in, take an Android keyboard view and plop it in. So it's not using a the sort of text view automatic keyboard. It's just one of those views that's dropped in there.
Yeah, I mean, that's definitely always kind of a challenge area. And unless you're like very serious about that particular application, it can be a lot of effort to test that portion. But still, I think it's an amazing prototype that you provided. And I certainly hope that you'll be sharing it online in other places as well.
Thank you.
Yeah. Okay. It looks like for now, that's all the questions that we have. That's quite all right. So oh gosh, okay, hold on. Just kidding. We have some stragglers. That's okay. I think this talk was like super engaging, and I actually learned quite a bit myself. I've definitely had some issues in other Android applications I've had, especially with dynamic scaling for certain things. And I don't know, it's usually kind of a bad time for me. Actually, I see multiple people typing again, so we'll just have to hold tight. I'm like just gripping the table with like anticipation. Yeah, so I guess like a personal question that I had is like, how long did it take to create the initial prototype for like just the scale that we were working with?
So I know when I first did this last time during our Maker Week, the initial version of this probably took me a few days to start picking apart examples and really get the feel for how it worked. And then I'd say it was a week all told between trying to kind of grok the mental model of reverse engineering other people's examples and the Java doc for the platform, and then building out the UI for ourselves. And that was, I mean, the amount of information out there now is a lot. There's a lot more and better information and documentation out there. So I'm absolutely certain that someone getting into this now is going to have an easier time of getting a tour of the platform than I did.
Oh, okay. All right, here are the questions. Okay, can you make a Compose view as a custom view and export it as an Android view? Apparently, I think I missed that question.
Yeah, I believe it goes the other way too. I just have not tried it. Yeah.
Oh, okay, no problem.
Yeah.
And then one last one, there's the CTA again. Let's see. So this person uses the Android NYT crossword. Here, I'll just. Okay, now everyone has had the Choose Chicago experience. If you haven't been interrupted, have you been in Chicago at all? Okay, so this person uses the Android New York Times Crossword app every single day. Do you have to do anything particular to allow rebuses to work and lay out properly?
Yeah, so that's the rebus question is what I haven't really dug into yet, and how to really do good auto scaling of that text. So we're actually using right now the auto sizing text view for rebuses that you get from the old paradigm of the Android support library gives you that auto resizing text view. So we're using that there, but I have not really found a good way of doing that yet in the Compose world.
Maybe that's what we're all gonna just like long await for as a cult. We're now a cult following, but no, really cool project. I don't know if there are any more questions at this time, but again, if you have any more, please feel free to use this channel, and of course you can always Slack bin too. All right, so we have one more talk for the day. We're going to take a quick intermission, and we're going to be back at 2:30. Ooh, not a whole lot of time. All right, thank you so much, Ben. Really great talk, and we'll continue on shortly.
Thank you very much.
Okay.